So today we're going to cover Chapter 8, Section 1. Today what we're going to do is talk about similar polygons. Now, when you have similar polygons, what they're going to be is they're going to be exactly the same shape. However, they're going to be different sizes. So remember that corresponding angles in similar polygons are going to be congruent. However, corresponding sides are going to be proportional. So if they give you a similarity statement like they did right here, the order of the letters is important. Just like we did with congruent polygons, similar polygons tells you what angles match here. So for example, the first letter is A, and it's going to match with the first letter in the second one, and that's M, and that's the first statement that was here. Angle A is congruent, and let me add a little wave here, is congruent to angle M. Now, the symbol for similar is just the wave, just the little wiggle that's on top of the congruency symbol. This is the symbol for similar. Then the next letter that we see in the statement is B, and it matches with N. And I can add the wave on top of all these. Because again, the angles are going to be congruent, but again, the sides will be proportional. Then the next letter is C, and it's going to match with O. And then the last one, D, and it's going to match with P. And these are all congruent angles. However, the sides will be proportional. So notice the first two letters, AB, is going to match with the first two letters in the second polygon, MN, and that's the fraction that was created right here. And then BC matches with NO, and then CD with OP, and then AD with MP. Now, technically, it doesn't matter if they ask you to write, this is actually called a statement of proportionality. They're just going from left to right. Now, when you're given figures, if they ask you to check to see if the two figures are similar, what you would need to do is check to make sure that all of the angles are congruent, all the angle pairs, and then also check to see that all the side lengths, when you put in all of the sides into ratios like these, that they all simplify to the same ratio. So for example, let me add some numbers to my figure, and then I can show you how you would check to see if all the sides are proportional. So let's say on the big figure here, I say that this top AB is 6. I'm just picking random numbers, a 10 and an 8. And then on the smaller one, I'm going to say that this is 3, 5, and then the two sides are 4. So if I were to take the numbers now and then plug the numbers into this proportionality statement, if I put AB over MN, 6 over 3 simplifies 2 to 1. Then, so this one was the AB over MN. And then if I do the next one, BC over NO, BC is 8, NO is 4. It also simplifies 2 to 1. And then if I take the CD over OP, CD is 10, OP is 5. It also reduces 2 to 1. And then the last one, AD over MP. AD is 8, MP is 4, and it also reduces 2 to 1. If these did not simplify to the same ratio, then these would not be similar polygons. Now, what we're also going to see coming up is a scale factor. And what you would do is you would take the ratio and you would come up with a scale factor, or what did they do to the first polygon on the left to make it turn into the polygon on the right. So if you think about it, what they did here to the 6 and the AB to make it turn into MN, it looks like they divided by 2, which is really multiplied by a half. So for the scale factor, you would have written it as 3/6, because what they did was they took this length of AB, which was 6, and they times it by 1/2 to get 3, which was the new length here. But we're going to see this coming up. This would have been the scale factor. But if they're just asking you to check on the ratios, it doesn't matter the setup. So the next slide is the scale factor. And again, it's going to be a simplified ratio. So if they're telling you that 2 polygons are similar, then the ratio of the corresponding sides of the 2 similar polygons will be your scale factor. Now notice both of these are equiangular, so all the angles are congruent, and that would mean that since it's equiangular, it's also equilateral. So it doesn't really matter which side length I pick to pair up. I would just take 3 and 6 and put it into the ratio. And again, since all the sides are the same, all I would need to do is 6/3, 2:1. And my scale factor, you could either leave it as 2/1 or 2. So whenever you want to find a scale factor, what you're trying to do is figure out what you're multiplying this by to make it become the new figure. And notice it looked like I times everything by 2. So my scale factor here is 2. Always reduce your scale factor, or always reduce your ratios. So for the next one, it wants me to find the scale factor of polygon ABCD to MNOP. So what we got to do here is go through and match. So again, the way that we can set up our ratios, see how AB is the first 2 letters? I'm going to match that with MN. So AB and MN would match. And then I could go back here, and then BC is going to match with NO. And then I can go back and grab CD, the last 2, and put it with the last 2 here. And then lastly, I can go from beginning to end and 10 with the 8. So now, to find the scale factor, what I need to do is find the pair that I've just circled that has 2 numbers, not a number and a letter. So that would have been the red one. Now, again, when you want to find the scale factor, we're trying to figure out what did we multiply the larger one, in this case, to get to the smaller one. So what I'm going to do is I need to take the right side and put it over the left side. So I'm taking the number that was in MNOP and putting it over the side length that it corresponded to in ABCD. And now I'm going to simplify this. So my scale factor here is 4 to 5. Now, if you recall back from your pre-algebra days, there are 3 ways to write a ratio. You can either write it as a fraction, and that's generally how you're going to see a scale factor written. You can also write it with a colon, or you can also write it with the word TO, 2. These are the 3 ways to write a ratio. However, generally, you're always going to see your scale factor written as a fraction. So now, they need us to find the values of x, y, and z. So what I'm going to be doing is I'm going to use that scale factor now, and I'm going to set up proportions to find the value of those variables. So to find x, and x was in green here. I'm going to do it in black so it'll show up better. So to find x, I'm going to take my scale factor, 4/5, and I'm going to set it equal to the ratio here that I set up. So again, I'm doing smaller to bigger, so I'm going to do x/4. And now what I'm going to do is cross multiply, solve this proportion. 5x equals 16. Divide by 5. And because this is a side length, I want you to make it into a mixed number or a decimal. So 5 will go into 16 3 times with 1 left over, or you could also say it's 3.2. Either way. Now to find y was in yellow. And let's see, this was green. And now I'll do the yellow, but I'll still write it in black so it shows up better. I'm still using the same scale factor. And now I'm going to take my variable y. So it'll be y, and its corresponding side is the 12. I'm going to cross multiply. 5y equals 48. Divide by 5. And 5 goes into 48 9 times. With 3 left over, or we could say it's 9.6. So this was the yellow. And now lastly, to find z. And z is in blue. So again, take the scale factor. And then I'm going to do z over 14. I'm going to cross multiply. 5z equals 56. Divide by 5. And z equals, 5 goes in here 11 times with 1 left over. Or it could be 11.2. I would accept either answer. So that's how we'll find the values of x, y, and z for part B. Now it wants me to find the perimeter of each of the figures. Remember, to find perimeter, we need to add up all the sides. So if I go back up here now, and I can see I've got all the numbers on the larger one. So all I need to do is add 10 plus 12, 10 plus 12 plus 4 plus 14, and the perimeter here is 40 units. Now for the smaller one, I just found all these side lengths. So x was 3 1/5. Z was 11 1/5. And y up here was 9 3/5. So now I got to add all of these. So let me add it over here. So I'm going to add 8 plus 3 1/5 plus 9 3/5 plus 11 1/5. Luckily, these already all have a common denominator. So once I add 1/5, 3/5, and 1/5, I get 5/5. And then I can add the number part, and this gives me 20, 28, 29, 30, 31. And then 5/5 is 1 whole. So the perimeter of the smaller figure is going to be 32 units. Now it wants me to find the ratio of the perimeters. So again, if I take my totals here and I put 32 over 40, notice if I divide them both by 8, they're both going to simplify 4 to 5. So what you're going to see is the ratio of the perimeters is going to be the same as the ratio of the side lengths. So whenever they're asking you to find ratio of the perimeters, remember it's the same as the ratio of the side lengths. So let me just say that. So the scale factor is the same as the ratio of the sides. Which is also the same as the ratio of the perimeters. All three of these ratios are going to equal the same thing. So after you calculated, say, the length of all the sides, and let's say you wanted to double check that you did calculate things correctly, if once you put those two perimeters into a ratio, if it doesn't simplify to the same ratio you found for the scale factor, then you've done something wrong. Everybody good there? All right. So here it says corresponding lengths in similar polygons. It says if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. So here it's telling us that these two triangles are similar. So the two triangles they're referring to are this one right here, TPR, and XPZ. This one right here. These are two similar polygons. Now, notice they both have the same shape. They're both triangles. However, the red one is smaller than the blue one. And that's what you're going to find with similar polygons. You're going to have a little one and a big one. Now, they want us to find the altitude of, or the length of the altitude, which is PS. So they're asking us to find the altitude of the red triangle. They gave us the altitude of the blue triangle. So again, I'm going to set up a proportion. Now, what I need to do is I'm going to find the side of the triangle that I have, the length of it. So in the red one, I have the length of TR. TR. It's going to equal 6 plus 6. So that length is going to be 12. And then I also have the length from the blue one of XZ. And that's going to be 8 plus 8, and that's 16. Now, again, if I want to find the scale factor, what did they do to the TPR to make it XPZ? Notice it's smaller and it's going to larger. So I'm going to do 16 over 12. So I'm doing the XZ over the TR. And then when I simplify this, it'll simplify 4 to 3, which is my scale factor. I'm now going to use my scale factor to find PS. So now I'll use my scale factor that I just found. It'll go in my proportion. And now I'm going to match the side PS with PY. So now I'm going to do 20. And I'll call PS, I'm going to call that X. And now I'll cross multiply. Because the proportion I'm setting up here is going to be XZ over TR equals PY over PS. That's what I just set up. So now I'll cross multiply. 4x equals 60. Divide by 4, and x equals 15. So the length of PS equals 15. Here's our first theorem of chapter 8. And this is the perimeter of similar polygons. Now, we already saw this when we did this in the other example. So it says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths, which is also the scale factor. So here they're telling us that these two polygons, KLMN, is similar, it's got the little wave, to PQRS. So this tells me if I add up all the sides in KLMN and add up all the sides in PQRS, then that's going to equal any one of the side length ratios. And it doesn't matter which. So just like we saw before on that other example, remember we had 32 over 40, which simplified to 4 to 5, which was also the scale factor we found on that other example. So for the perimeter, remember the ratio is the same as any of the ratios of any of the side lengths, which is also the ratio of the scale factor. Now for the area, we're going to take the scale factor or the side length ratio and we're going to square it. And that'll be our next theorem. So the next theorem is the areas of similar polygons. So if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So once you find a ratio of one of the side pairs, you would just square that ratio and that would equal the simplified ratio of the areas. And we're going to do an example of this on the next slide. So here in this diagram, they're telling us that polygon GHJK is similar to LMNP. It wants me to find the area of the larger polygon LMNP. So I'm going to use the ratio of the side lengths. I'm going to put that into a ratio and then I'm going to square that ratio and then I'm going to use the ratio in my proportion. So the ratio of the side lengths or my scale factor would be to take PN and put it over KJ, because again, PN is the last two, and so is the KJ. So if I take those sides, I end up with 21 over 7, which reduces to 3 to 1. Now, this is the ratio of the side lengths, which is also the scale factor. Now, remember, this would also be the ratio of the perimeters. However, for the ratio of the areas, what we're going to do is take PN over KJ, and we're going to square it. And that would give me the area of LMNP over the area of GHJK. So let's go ahead and try it. So what I would have done is take PN, 21 over 7, square it. They gave me the area of GHJK to be 84. And I'm going to let my area of LMNP to be my X value. Now I'm going to simplify this. I don't want to have to square 21 and square 7. And then this would give me 9 over 1. And now I just cross multiply and divide. So X equals 9 times 84. 9 times 84 is 756. And the thing was labeled here with meters. So area is always the unit squared. So 756 meters squared is the area of the larger figure, which was LM and P, 756 meters squared. So remember, you just take the scale factor or the side length ratio and you would square it, and that will give you the ratio of their areas. So we're using proportions in this chapter to find the missing side lengths, because the side lengths are no longer congruent, they're proportional. And that is it for the notes on 8.1.